Hello everybody, welcome to Math Circle Science Education. Today we are learning Introduction into Complex Numbers. So the first thing is, what is imaginary numbers? Imaginary numbers is a number in the form bi, where b is a real number and I is the square root of -1. So if we do some examples, basic examples, the square root of 4, that's easy, is 2 because 2 times 2 equals 4. But let's say if it's square root of -9, we can write it as square root of 9 times square root of -1, because I equals the square root of -1. So we can write it, so if the square root of 9 is 3 and -1 and I equals the square root of -1, then your answer should be 3i. Let's do more examples. Examples like the square root of -36. You can write it as the square root of 36 times the square root of -1. So the square root of 36 is 6. And we know that I is equal to the square root of -1. So your answer should be 6i. Now, you guys should do a practice on your own. I'll give you a problem. Let's say, let me get a new marker. Much better. Square root of -81. How would you, so you use the product of property of radicals to simplify the following radicals. So I'll give you guys a second to figure this out if you want to pause the video. Okay, so you can write it as square root of 81 times square root of -1. So the square root of 81 will give you 9. And the square root of negative 1 is I, so your answer would be 9I. Okay? Let's say square root of negative 50. There's no two numbers that multiply each other that will give you 50. So 50, square root of 50 times negative 1. So how can we find the two same numbers that multiply to each other that gives you 50? Well, we're gonna need to find two factors. Okay, so 50. Let's see. I'm doing like a tree factoring. So, any numbers. 5 times 10. Yeah, will it multiply by 50? I'm highlighting the 5 because there's an 5 that can't be simplified anymore. The 10 could be simplified by 2 times 5. And the 2 and a 5 also doesn't simplify. So we can write it as square root of these three numbers. 5 times 5 times 2. So we can, since these two terms, the same two terms, we would circle those two. And since 5 times 5 is 25, the square root of 25 is 5, we would move the 5 over here as you're right there. And then you'll be left off. And then also the square root of negative 1 is I. So your answer should be 5I. And the I must be right here, not right there, or after the radicals. Square root of 2, and that is your answer. Okay. Alright, now we're going to learn about powers of I. So, when you're, let's say I to 15, I power to 15. If you want to find if you want to complete this kind of expression, we can say 15, you can say 15 divided by 4, and I'll explain why divided by 4. Multiply, so you get 3. You will be left off with a remainder of 3, okay? So the remainder of 3 is negative I. So I15 equals negative I. That was just like another example. So now I'm gonna make a chart. So let's this chart would probably help. This chart would actually help. Okay. Let's do that. Alright. So we know that I is negative 1. So when there's a remainder of 1, for example, wait, I'll show the example later. So I is square root of negative 1, so that would be I. That's the answer. When there's I power to the 2, or when there's a remainder of 2 when you're dividing, it will be like square root of negative 1 times square root of negative 1, and that'll give you negative 1. So, and I show you when there's I to the power of 3, we can write it as negative 1 times I, and that will give you negative I. Because you can also put it like I to the power of 3 equals I to the power of 2 times I. So when you're multiplying the exponents, add. So you can this could be as I to the power of 1. These 2 and 1, they both add up to 3. And that's the rule, negative I, part of the rule. I to the power of 4. Write it as negative 1 times negative 1. Just give you 1. What about I5? What would that be? Well, you can write it as 1 times I back to I. So the reason why we divide it by 4, like when, for example, I'll put it right here, I32, I to the power of 32. If you want to find what does I to the power of 32 equals to, well, the reason is because it's like a cycle of the powers of the I. So from here, 1, 2, 3, 4. That's 4 times, and back to original. If it's I6, you could probably guess what would it be next. What the answer would be. Write it as negative 1 times 1. Look, negative 1. Right there. So after 4, you can say after 4 powers, it comes back to I and then repeats down. So after I, so I to the 7 would be negative I to the 8 would be 1, and then I to the 9 would be back to I, and then repeats and repeats. So if I to the 32, if you want to find out 4, probably put there 4. Rotates every 4 actually. That makes make sense to you guys? Rotate every 4. So that's why we divide by 4. Oops. 4 divided by 32 gives you 8. So there's no remainder. So that means if there's no remainder, that would be, the remainder means it's just 1. Alright. And yeah, no remainder is just 1. So you can, so this is everything you want. This is everything to summarize it. One. That's I as 1. So it could be, you could put it like that, or you don't have to. Just I. Then rotates to I square equals -1. Then rotates to I cube equals -I, and then rotates back to I4, and then yeah, so on. Okay. Okay, so when you're solving complex numbers are in a form, are in the form of A, should probably put parentheses. You don't have to put the parentheses, I just put that so you guys don't get confused or so. A plus BI, where A and B are real numbers. And I, you can already guess what I is. I is the imaginary numbers. Imaginary numbers, or imaginary number. And it also equals to the square root of -1. Okay. Okay. A little bit, question right here. Check each statement. Actually, check each true statement about the number the number 7 minus square root of 3i. Alright. Alright, so the first one is, that's a dot, say you know, like ABCD. Alright, first one, 7 is the part of the number. I'll actually make a box. Second check mark. Alright, first one. 7 is part of the number. There are 4. Okay. There you go. For answer choice. But it says check each statement about the number. So there are multiples. Square root of 3 is the imaginary number. Imaginary part of the number. Third one is 7 minus square root of 3 is the coefficient. Coefficient of I. And then last one, the number. And the number is the sum of a real number and an imaginary. Imaginary number. Alright, let's go one by one here. So first one, 7. 7 is the part of the number. Yep, it is a number, and it is part of a number, so check for that one. The square root of 3 is the imaginary part of the number. Yes, it is part of the imaginary number because 3i, that's an imaginary number. So yes, and it is part of it. I meant to put underline that. Next, 7 minus square root of 3 is the coefficient of I. Nope, that is not right. The number is the sum of a real number and an imaginary number. Yes, that is true. Number is the sum of a real number and an imaginary number. Yep, because when there's two expressions that multiply each other, or it will give you this answer, and it does give you a sum, or if you're adding, it does give you a sum of that, and it does have a real number and an imaginary number. Moving on to complex numbers in a plane. Complex number in the plane. So if we're plotting numbers like 1 and 2 on a plane, just pretend this is your x-axis. Just pretend that. And that. And we put 4, put 0 right here. Just pretend. And if we put 2 and -1 there, the x-axis is your real number, and if we're plotting, let's say, let's draw that. This is the vertical line, known as your y-axis. Let's say, let's plot -2y and 3i. Okay. -2i would be, let's say, down here, -2i. And then 3i would be up here. This is your It's just like an ordinary plotting points, except horizontal is the x-axis is your real number, and the y-axis is your imaginary number. Imaginary numbers. So, for example, let me draw that. For example, let's plot -1 minus 2i. So we know -1 is a real number. So let me there you go. Let's draw some lines. Alright, -1. So we know that the x-axis is for the real numbers. So -1 is a real number. So -1 right there. Let me label that. That's -1. -2i. So we know the y-axis is for the imaginary numbers. So, and it's negative, so it's down here. -2i. So we plot that. That's where the dot goes. And that's how you plot -1 minus 2i. And let's see, plot 2 plus 3i. Alright, 2, we know 2 right here. It's on the real number line. And 3i. 3i, it's your y-axis. So 3 right there. So there you go. 3i. This line. And then that's how you plot complex numbers in a plane. I really hope you guys understand this. If you guys have any questions, you can ask me in the comments. I'll for sure explain it to you guys. And let's do more problems. So, alright, just a little review. I-32, okay. You're free to go back to the video, to scroll back to see if you need help or anything like that. So I-32, okay. We know we're gonna need to divide 32 by 4, so we already know how to do this. Oops. Gives you 8. 0. No remainder. So we know that no remainder means it's 1. Okay, so that was just a little review right there. And now another review, you know? Yeah, I'll give you another review. Square root of -144. How do we solve this? Well, we can write it as 144 times -1. Get rid of the negative. And I is -1. So we know that I is equal to -1. So we know that for our answer, I is part of the answer. And the square root of 144 is 12. That is your answer. And it is a imaginary number. 12i is an imaginary number. Alright. So next. Okay. Now we're moving on to adding and subtracting complex numbers. So first question, add -12 plus 4i plus 9 minus I. Okay. Well, we can do combining like terms. Like 12 and 9, 4i and I. So when you're adding -12 plus 9 will give you -3. 4 plus -I will give you plus 3i. And that's the answer. Oops. There you go. Okay, how about, what if they say the sum of 3 minus I, 5i, plus -2 plus 8i. The sum of 3 minus 5i plus -2 plus 8i is, so what do we do? Well, you just add, you just find the sum, pretty much. So combine in like terms, that'll give you 3 plus -2 give you 1 plus -5i plus 8i is 3i. That's your answer. That's how you add complex numbers. Alright. Now, subtracting. That's a good one. A lot of people make mistakes on the signs. So 10 minus 3i minus -5 plus 7i. Alright. Well, before we do anything, we can do keep, change, change. So we can change, we'll keep the signs on this side, change this sign. So it'll be plus +5. My marker is not working. Let me fix this. Plus 5 minus 7. Excuse me for my markers. Okay, so now we can combine like terms. 10 now. Oops. That one and that goes there. So 10 plus 5 gives you 15. 15 minus 10i, because -3 minus 7 gives you -10, including the I. That's your answer. So always change the sign. Keep, change, change, including change this this expression right here when you're subtracting. Okay. What is the additive inverse? What is that? Well, it is a, well, wait, let me show you. Additive inverse of the complex. The complex number A plus BI. Remember the form A plus BI? That's how complex numbers should be written as when you're as your final answer is negative A minus BI. So you pretty much change the signs when it's asked for what is the additive inverse. So for example, and oh wait, also the sum of a complex number and its additive inverse is 0. Just keep that in mind. I'll show you an example of what I mean by that. So, for example, 5 plus 4i plus negative 5 minus 4i, because we changed the sign. And when you combine the like terms, it'll give you 0. Okay? So now, what is the additive? What is the additive inverse of negative 2 plus 8i? Well, change the signs. So it'll give you positive minus 8i. Pretty much, it's simple, basic. Now you can just do some examples, some more practice with imaginary numbers. So solve 5 square root of negative 8. So let's solve this. Okay, we can write it as 5 times 8 times negative 1. Okay, so we know now we have to find what the square root of 8 is. So 8. We can do our factor tree. Let's 2 times 4. We'll highlight 2 because 2 can't be simplified anymore. So 4 could. 2 by 2. Highlight those two. Okay, so we can write it as 5 times square root of, oops, use my radical. 2 times 2 times 2. Like I said, circle the 2 ones, because 2 times 2 is 4. The square root of 4 is 2, so 5. It would be 5 times, oops, wait. 5 times, so it will give you, pick out 1, 2, and move up here. 5 times 2. I, remember, because the I, negative 1, square root of negative 1, I equals square root of negative 1, and then you left over with 1 of the 2, so you put 2 there, so you give you 10i square root of 2 as your answer. And that would be it for today, guys. I hope you guys enjoy this video. I'll for sure try my best to make this video as good as possible on helping you guys. This is my first time filming this, so thank you guys. I really hope you. And please like this video, subscribe, and ask me any questions if you need. You can also visit Khan Academy for more help, or IXL for more help. On this, they really have great lists of math topics that you need help on. Really good help. And I'll make more videos on this stuff. Thank you guys for watching, and bye.